Konferansımızın son konuşmasında antistatik yük ve olayları nasıl görünür hale getiririz sorusuna cevap arayacağız. Desco Europe marka müdürü Sayın Steven Burns bize bu sorunun cevabını verecek. Kendilerini de sahneye davet ediyorum. Buyurun.
My name is, good afternoon everybody. My name is Stephen Burns. I'm the brand manager with Desco Europe. We're a division of Desco Industries. Desco Industries has been in the ESD, the static control business, for around 40 years now, and we are a global leader in this field. We're delighted to be invited by Yildirim to be with you all at this conference today. And the topics for today that we'll be discussing over the next few minutes is that, first of all, we'll have a look back over ESD control, static control in the electronics manufacturing arena over the years to see where it started from, where it is today, and also where it's heading. And then we'll take some time to discuss the solutions that are on offer for today's electronics manufacturers. So looking back into the past, what was ESD control all about in the past? Well, first of all, ESD control, because electronics assembly was largely a manual operation, it was on the workbench. ESD control was also on the workbench. It was focusing on the individual operator at the workbench, hand soldering, handling older components that had a certain level of static susceptibility, but certainly not the levels that we see today. And so the European standard and the American ANSI S2020 standard were developed with those things in mind. So they would consider the human body model, which was the most common type of ESD failure. And they would be looking to control events to no greater than 100 volts human body model. And at the time that those standards were conceived, that was sufficient to prevent the vast majority of ESD events that would damage that product. Since then, there have been huge changes in electronics manufacture, two in particular that we will focus on today. Or consider first of all. One is miniaturization of components, and hand in hand with that goes the increase in susceptibility, or rather the lowering of the level at which components can be damaged. The other big change is, of course, automation. We're moving away from the workbench with the manual operator, hand soldering. That, of course, still happens, but we move towards automated manufacture, SMT lines. What are the solutions for ESD control when, let's say, 90%, 95% of electronics assembly is now automated rather than manual? Perhaps only some topics like R&D or prototyping or some very specialist work is now manual. So we need to have a solution to protect our product from not human body model, but charge device model events. This is, and we can explain the difference in these a little bit more, but the failure mode is different when you consider a person to component contact and metal to metal contact. There is a different discharge speed, which we can discuss. So we need to move on from talking about 100-volt human body model to talking about 20, 10, 5-volt charge device model. One of the let's say, the first changes that a lot of companies will make as they start to handle more sensitive devices, and this is still at the workbench. One of the changes that they will make is to look at continuous monitoring for workstations, for work surface matting, and for wristbands. Perhaps you're familiar with these already. These are actually not required by the standard. The ANSI S2020 standard and the IEC 61340 standard don't require continuous monitoring, but they are a common step forward for manufacturers who are handling more sensitive products. They need to go beyond the minimum requirements of the standard, because actually what matters is not compliance to a standard, but protecting your product. Another challenge that's presented by automation is that when you have a series of processes lined up into one automated production system, it's very difficult to tell. Let's say a board comes out the end of your production system and you discover a failure, which you can then attribute to static failure. Where back through the production process do you look to find the cause of the failure? When you're doing hand assembly, perhaps it's more obvious. You know exactly where components and boards are in intimate contact with an operator. Through an automated production line, it's much more tricky to tell exactly where the risk may come from. And so the next change, along with continuous monitoring, is to consider data acquisition, which will allow you to collect data at various points through your process in order to isolate and resolve the cause of the failures. Very time-consuming to go back through a whole production process and try and figure that out looking backwards. Much better to have the information immediately and resolve it proactively. And so if that's the state of electronics assembly today, what does the future look like? Well, actually, these trends show no sign of slowing down. More and more components will become smaller, more and more susceptible. More and more processes will become automated. We've just seen through-hole soldering going to robots instead of manual operations. It's not going to slow down. This trend will continue. And the different applications for electronics are broadening all the time. We saw one in the previous presentation. But if you just think about the car, I remember my first car. I don't think there were any electronics in it. Maybe not quite. But today, almost nothing in your car functions without involving electronics somewhere. Electronic handbrakes, for example. Even your seatbelt, your car will tell you if you didn't plug it in. And so this is going to become inevitable. This will become part of every manufacturer's process. Simply, it will be the expectation to participate in electronics assembly, either as an OEM or as an EMS, will involve this level of monitoring and process control for ESD. But more than the expectation, it also allows you to have a high degree of confidence in that automated manufacturing process. If we are moving the assembly to automated processes, we need to have confidence that the product that's going through that process will get out the other side, not just working, but working tomorrow and next week and next year. And in 10 years' time, in some of the arenas that we're working in, it is essential, critical, that product is reliable, medical, automotive, aerospace, defense. It's one thing if the product fails when it comes off the production line, you can stop it going out the door. But once it's in the field, it must work. Reliability over decades is what's at stake. So with continuous monitoring and data acquisition, our mindset is like, again, to use a car analogy, it's comparing having your car serviced to having a dashboard that tells you every time there's a problem. So again, I don't know about you. In years gone by, I would maybe check the pressure on my car tires, I don't know, every few months, maybe just when the car went for service. Today, my car tells me immediately that the pressure in the tires drops. So the process changes from reactive and discovering a problem after it's been there for some time. Now I know immediately that there is a problem and we can take action immediately. So the question is, what is the solution on the market to solve this kind of a problem? What are the tools available? Well, we've mentioned the two main things. I think it's come up on the bottom of the slide there. Continuous monitoring, continuous validation, and data acquisition, which allows for remote visibility. This allows you to know every moment that your product is protected. No guessing, no hoping, no finding out when a batch of 10,000 boards has been run that 20% of them have failures. Or no finding out in 6 months' time when a batch of product has shipped that now you have a lot issue and you have to issue a recall. No worrying about loss of confidence in your brand, or potentially critical application products failing in the fields. These monitors will also allow you to look at the whole scope of your ESD production. We are still concentrating on the manual handling of electronic assemblies, and we're also looking at the automated production when 95% of the manufacture happens. And if you consider the role of the ESD coordinator, I have met, I think, 3 people in my time. I have been working with Desco Europe for 15 years. I think I've met 3 people in my time where their 100% job was ESD coordinator. Every other ESD coordinator I have met also has 10 other tasks, 10 other responsibilities. ESD coordinator is one responsibility among many. So how happy would your ESD coordinator be if you can provide them with tools that make their job that much easier, more reliable? They are able to deal with ESD issues as they happen immediately on a proactive basis, rather than finding out at an audit that some things are out of specification. Another potential way to use this system, possibly if you're in the contract manufacturing or EMS arena, is to be able to provide your customers with a report at the end of manufacturing their product to show them, here is the ESD report, here is the report on the ESD process throughout our handling of your product. You can have confidence it was protected 100% throughout. Continuous validation, if I can tell a little bit of a story, there is a lot of requirements in the European standard for regular testing of all sorts of things. The most regular test is for ESD wrist straps and for footwear. Most customers will test these once or twice a day. Most other things have a longer gap than that, but wrist straps and footwear are a good example for daily testing. So you can imagine how the testing goes. On Monday morning and Monday afternoon, you pass. Tuesday morning, Tuesday afternoon, you pass. Wednesday morning, you pass. And then on Wednesday afternoon, you fail. The thing with the failure is that you didn't just get a fail on Wednesday afternoon, but also you now have a big question about Wednesday morning. Everything that I handled after my test on Wednesday morning is now a question. I don't know, when did it break? I could have tested my wrist strap, taken it out of the tester, and it broke that moment. And everything in the morning is now a question. We call this the gray zone for exactly this reason. That period between your last good pass and your fail is now gray. When did it fail? The purpose with continuous monitoring is to shorten the gray zone down to moments, seconds, split seconds. Come to the back afterwards and I'll show you exactly how that works with a range of parameters. But this is true for wrist straps. As I mentioned before, lots of companies will use continuous monitoring, but this is also true for all sorts of metrics. For example, work surface validation grounding, or metal tools, metal grounds for your machines. On an SMT line, you might have 25 ground planes that you need to make sure are grounded all the time. Imagine if you tested every ground plane, you'd never stop. As soon as you finished, you'd have to go back to the beginning and start again. Continuous monitoring will do that for you. And remote visibility through data acquisition and software will allow the ESD coordinator to manage the whole process, to see the whole process, and to manage the whole process from his desk. He doesn't need to go all the way along the production line and along every single workstation to know that every mat is grounded, to know that every ground plane is correctly bonded to earth, to know that every operator is wearing their wrist strap as they should be. Remote visibility. These are the three hardware devices that are involved in this process. We're going to look at each one of them in turn very quickly, and then again, I welcome you to the back to review these devices together with me in real time. So the WS Aware, this is our workstation monitor. This will monitor 2 operators, 2 work surfaces, and 2 metal tools. So the metal tools could be soldering irons or electronic screwdrivers, or they could be chassis of the bench, or any hard ground, any low resistance ground that you would like to monitor. It will monitor 2 of those. The ground master over here, actually the 8 channels are exactly the same as the metal tool fixture on the WS Aware, but this has a primary application on the SMT line where you have lots of ground planes in a row. So it has a particular application there. And then the EM Aware. This monitor will detect static voltage, so any static voltage that builds up in the SMT line or on the workbench, it will monitor that. And then if there is an ESD event, it will detect that. So the way that works is it's an antenna and it's a signal recognition system. As the signal changes when there is an ESD event, it recognizes that waveform as an ESD event. It will detect the amplitude of that ESD event, and then using a proprietary algorithm and the settings that the user inputs, it will estimate the value of that ESD event. So you can imagine throughout the course of the day, on the back of the workbench, it can tell you if you had no ESD events or if you had 20 ESD events, and also the size of those ESD events. If your device is damaged by, let's say, 50 volts, charge device model, you can set the parameters in the software so that it ignores everything that's less than 50 volts, and it will tell you about any events that are greater than 50 volts. ESD event detection is something that our industry has been looking for a long time. How do you know ESD events are happening? It's all well and good, people like me saying that it is happening, and it's also well and good to put mats and wrist straps, but how do you know it solved the problem? Well, now you can know. Now you can know that you had a problem. Now you can see the problem. And when you put solutions in place, now you know that they really are solutions. Now you know the problem went away. And the final function of the EM Aware is that it's also capable of monitoring ionizers. So again, to take that gray zone illustration again, if you validate your ionizers once per year, and it tests fine in year 1 and year 2, and then it fails in year 3, that's 12 months of potentially this ionizer has been causing a problem instead of solving a problem. Even if you reduce that to 3 months, how much product goes through your production line in 3 months? The EM Aware can be used to continually monitor your ionizers. We'll talk a little bit more about that in a second. So, monitoring operators, 2 metrics are being monitored. One is body resistance, of course, that they are actually connected to ground, and that's within the specification of the European standard. The other is operator body voltage. There can be many reasons why voltage from the environment can be coming onto the operator. Potentially, it's machinery that's on an ESD floor and the operator's wearing ESD footwear, and that voltage will come onto the operator. If it's on the operator, it will go onto every product that they handle. So this monitor will also alarm if the operator is grounded but is carrying a voltage on their body. Ground resistance for the work surface mat, and then 2 parameters for hard grounds. And again, this refers to the ground master as well. Ground impedance is one thing, so that it's actually bonded to ground. But then EMI voltage. EMI voltage can be caused by RF signals in the atmosphere, which are picked up by potentially the earth loop, the electrical earth loop, potentially by the chassis of other machines. And that EMI voltage will then flow through SMT lines, pick and place machines, and potentially then will run through your boards and your components. And EMI, this is not really an ESD issue, but this is a cause of electrical overstress, which actually has the same kind of failure modes as ESD events. So we can monitor for EMI voltage and protect your product against electrical overstress risk. Ground master, as I mentioned, is monitoring those same parameters. And then EM Aware, we already mentioned, monitoring static voltage, ESD event voltage, both the raw value and a calculated value. And then monitoring ionization, both the offset voltage, the balance voltage, is your ionizer within plus or minus 35 volts required by the European standard. And then decay time, every few minutes it will perform a positive and negative decay time test and make sure that that is within the 20 seconds required by the standard. This second test here, the decay time test, will also tell you if somebody has switched off an ionizer. An ionizer that's switched off will not pass a decay time test, and you can tell if your ionizers are switched on and working and compliant to the standards. Remote visibility, as I mentioned, all of those parameters that we just went through are fed back. These are Ethernet-enabled devices, so it all goes back into central software. We have just launched, or we're about to launch, a web-based version of this software. It's not on the cloud, it's on your own systems, but it's accessed through a web interface so that multiple supervisors and administrators can see the data all at once and have access to it, see what they need to see. Not just live data, but also historic data, so you can run a report and see the day's events. You can run a report per device or per line or per factory, whatever the scope you need. And you can imagine that you could use this report, again, to produce with a production run to show compliance throughout the whole process. We know that as we ran our product on the 25th of October, our ESD processes were firm and secure. If there are problems, there are built-in troubleshooting tips for each type of failure. So it will walk you through, here are some things you can do to resolve the problem, to diagnose and resolve the problem. It will give you areas to concentrate on. So by displaying it graphically, it will give you the most common failure modes so that you can then deal with the most problematic issues to begin with. There is also the possibility to use the EM Aware to triangulate and find the source of a problem. This was super useful for lots of our customers who they had EM Aware monitors installed throughout their machine, and they were seeing ESD events, but they couldn't find the source of the ESD event. So they set up 3 EM Aware antennas like this. And then they ran the process and they looked at the data produced. You can see it just about on the screen there. It's more obvious when you look at the software, but actually they were able to see that the event was closer to monitor 2. Now, this doesn't go into all the detail, but actually what they did then was they left monitor 2 where it was, and they moved the other antennas. So slowly, like a dragnet, slowly they moved it closer and closer until they identified down here that there was a loose ground wire. And every time this ground wire moved and contacted the chassis, there was an ESD event. So they were able to use this technique to find the exact location of ESD events. Potentially, it can seem a little daunting to imagine putting these systems throughout the entire factory. We don't imagine that many customers will do that. Instead, what we have created is 4 kits, and you can see one of them at the back. Do come and see us afterwards. That will allow you to, it will provide the monitors that you need depending on your application, and we can help you determine the best kit for your application. It'll also include network hardware and the SMP software license. And the idea is that you will install it for a time in an area where you need to determine the reliability and the effectiveness of your ESD control processes in that area. And then decommission it from this area and take it to the next, perhaps the next most critical area, and do the same again. So there's no need with this system that it should be permanently installed. It can be used, as we highlight here, as a diagnostic approach to make sure to establish a clean bill of health for your ESD control processes. I'll mention again that we are at the back on the left as I look, so do come and see us for demonstrations, but also after the event. We are available to meet with you by virtual meeting, Teams meeting, and we can do a live demonstration so that you can see these products at work whenever is suitable for you. So contact through Yieldrim, and we'd be very happy to run through all that with you. And that's me finished. shall I invite for questions?